The next question would be how to collect data from that population in a way which gives us uh, the best possible output, obviously, which will represent the entire population. I mean, which will be good enough to estimate what might happen with the entire population, right? Okay, so now what should we do? Where should we collect data from? Obviously, again, it looks impractical, right? To collect data from each and everyone in a city or even in a county. It looks impractical, right? So uh, we want to pick up a smallish set. We want to pick up a sample of that, and it has to be the representative of the entire population. Excuse me. So if we go back to the job we had of the pollster, because if you remember, uh, you are hired. Let's say you are hired for collecting data for either from the ruling party or the opposition party, and as a pollster, you want to give him the prediction what will happen in the election. Just a quick reminder for you, if you have forgotten what we actually did uh, on Monday. Okay. Oh, is it anyone trying to say anything? Looks like it's okay. Anyway, yeah. So I'm keeping an eye on the screen, but if you have any question, please unmute yourself. That would be more convenient for me to um, answer, or rather uh, to keep track what you are, if you are trying to ask any question. Okay. All right. Now, um, what's the best way comes into your mind when trying to sampling um, the population? Where should you go and pick people from which might be the representative of the entire population? Can you imagine anything that you can do? Let's say you are the pollster, right? Let's imagine you are the pollster. You are doing the job of collecting data. So obviously you can't go to everyone, right? So can you imagine uh, going in a place and collecting data from there? Anyone? Just give it a thought. What could be the best way, or what could give you a better result? Where should you go, or what should you do? If I say, let's go to uh, the Union Ballroom and let's collect, let's start collecting data from that. We're talking about Laramie, right? So let's say we are collecting data for the people, or from the people of Laramie. And as a student, what I might do, um, I might go to the campus, although it's uh, online now, but let's say it was on campus. And I might think that, hey, if I go to the campus and start collecting data from uh, the eligible voters or registered voters, do you think it could be enough? It could be the representative of the entire population? Anyone?
It's representative of the voting population, but not of everyone.
Well, obviously, we want to collect data um, for the, I mean, uh, the registered voters. If you remember, the registered voters were, or rather, is the population. The registered voters are actually a part, or actually they consist the population.
Okay. Okay, I
So,
get it.
yeah. So now, do you think that if I start collecting data from the registered voters at our campus, now do you think it should be good enough?
Not really. You might want to go to different places around Laramie if it's just registered voters in Laramie that is the population. Otherwise, it would just be registered voters who are students.
Exactly. So if I just go to the campus, if I just go to, let's say, uh, Walmart, if I just go to Starbucks, if I just go to a single place, it might not be enough, right? So for a better result, what you need to do, we call, you need to pick, I guess you have seen tons of times from me. I have used this word random, randomly picked up, right? I think I have said this several times on Monday and even before that. So this randomness is important. So let's see. Here you go. Let's see what we want to say about it. So if you want to uh, if you want to find a sample, proper sample of the population, the best way is to uh, employ randomness. That means if you start picking up people randomly, I mean from different places, and obviously there will be some issues which we'll discuss just soon after we see the definition. But if you start picking up randomly, that means don't stick to a particular place, or don't stick to a particular age group, or don't stick to a particular race or ethnicity, then it might give you a better result. So we say that a random sample, as you can see the definition, is one in which each member of the population has an equal probability of being chosen. Now, here is a quick reminder. I said I want to go to the campus and start collecting data from them. Now, imagine you are a registered voter, but you don't really belong to the campus. You are not a student, you are not a staff, you are not an instructor. So, do you have uh, equally likely chance of being picked up by the pollster if you are a student, and if you are somehow connected to the campus, and if you are not? Can you see the difference? First of all, is the question clear? Just try to imagine this. Let me say this. uh, we'll not be doing too much mathematics in this topic. All we want to know and go deep into the definitions. You'll be, I think you have already done the homework, and you have already seen that we'll be playing with the definitions, and we'll try to derive uh, informations from the question and put it in the definition to see which one matches the data set. Okay, whether, for example, we'll soon see different types of sampling methods, and in the question, in the homework question, you will see the data set will be given. You will not be asked to do any maths there. All you need will be asked to do is to match those data, or rather those informations, to the definitions you know, and then find which fits the data set. uh, and probably it will be a multiple choice questions, or just a short answer question like that, no maths. So I want you guys to understand what's going on, okay, with the definitions. So let me ask you the question again. So you are not affiliated to the campus, and let's say I'm affiliated to the campus. I'm an instructor. So if let's say Azizi is the pollster, he's collecting data for the next election, and he just went to the campus for collecting data. Now, do you and I have the same probability of getting picked by Azizi for the poll? Anyone? Just give it a try. If you want me to rephrase the question, I can do that. Uh, if you're writing in the chat, then I might not be able to see that while I'm keeping an eye on the other screen. So if you can unmute yourself, that would be better. No one, just give it a try. Do you want me to rephrase the question, maybe?
Yeah, can you rephrase the question, please?
Sure. So again, let's say GZ is the pollster, okay? He goes to the campus to collect data for the next election, which we are discussing since Monday. And as an instructor, I'm affiliated to the campus, right? Uh, I'm working on campus, so GZ might find me somewhere, right? And there are several people like me as well on campus, students, staffs, instructors, and all that. And let's say Stephanie is there. She doesn't belong to the campus. Um, let's say she actually is in Colorado, for example. So now, when Azizi starts collecting data, does Stephanie and I have the same probability of getting picked up by Azizi for collecting data? Okay, so you're saying no, the probability is not the same. Okay, why? Painter, can you please explain? Just give it a try, even though, even if it's wrong, no problems. Why do you think it should be? You said no. Why do you think it's no? It's a no. Why? Why the probability should not be the same? Because the chance of running into Gigi in campus is much higher than Gigi who is not on campus. Right. So when a GZ starts picking people for collecting data, Stephanie is not even on campus. So definitely, it's there is no chance that he will actually pick up Stephanie for collecting data, right? Because she is not even on campus, and Aziz is only collecting data from the campus itself, from nowhere else. So actually, Stephanie has a zero chance, okay, just a big zero chance of getting picked up by Azizi. Can you see that? So we say it's not a random sample. You know, when Stephanie doesn't have the equal probability of being chosen as me. Since I was on campus, she doesn't have an equal probability of being chosen. So that can't be a random sample. For a sample to be random, everyone in that population has to have the equal chance of being picked up. So if I don't define this way that Azizi is picking up people from on campus only, if I just say he's collecting data from the eligible or the registered voters of Laramie, if I just say this, then Stephanie and I would actually have the same chance, the same probability of being chosen, because he might be collecting data over phone. He might do that over phone. He might go to different apartments, different places. So Stephanie, although is in Colorado, since she is the registered voter, she may not be right now in Laramie. She may not be right here, but assuming that she will come back. So when Azizi, let's say, will go to her apartment in Laramie where she used to stay, he will find information about her, and he might call her as well to collect data. So when I do this randomly, then everyone has an equal chance. If Azizi starts collecting data, when he goes to Walmart, let's say he collects data from there. Then the next day he might be walking around the downtown, and he will collect data from there. He might go to the uh, um, Grand Avenue, and he might start collecting data from that avenue the next day. So if he does this randomness, then definitely everyone has an equal chance. He's not sticking to a particular place. He's going different places. He's trying different things. Then there is a randomness, and everyone has an equal chance. Does this make sense? The first question could be, is there any confusion about the definition itself? Anyone? Any questions you have? Oh, the 15th Street will be closed today. Okay. So if you're going to use the 15th Street today, you can avoid that, because I guess the street will be closed for some reasons. Anyway, yeah. So, any questions from the definition? Because again, you will be asked to match these definitions with the given informations you have. Soon, I guess not today, but probably within next two discussions, yeah, you'll have your next homework, and again you'll be asked to do similar work. A story will be given, and from that story you'll be asked several questions, but all of those will be really, really short questions, or even multiple choice questions. No real maths will be there. Okay, so try to understand the definition pretty well. It will help. Okay, you can always go back to the definition and memorize it, but I don't think memorizing would be sufficient if you don't understand. I may be repeating myself, but anyway, no questions. Looks like no questions. So let's move on then. Yeah, we have an example. Cool. We can work with this now. All right. So example 7, it says, if we could somehow identify all likely voters in the state, put each of the names on a piece of paper, toss the slips into a hat, and draw 1,000 slips out of the hat, we could have a simple random sample. All right. So what we're doing here is, let's do it this way. It might make more sense. Let's say we are doing the survey on this particular course. We have 38 students in total. So what I'm doing today is I'll be randomly picking up. I shouldn't say randomly, but I'm just trying to convey what I'm trying to do here. Okay, so I'll be picking up students' names, and I'll ask questions to them. Okay, obviously in a 50-minute lecture, I can't really ask questions to all 38. So what I'll do, I'll ask questions to a smaller group of that. Okay, so I'll pick up a sample. Okay, so now I'll write the names of all 30 students, and I'll have all those names in a sealed envelope, so that I don't really know in which envelope I have, uh, you know, I can't really see which name I have inside which envelope, right? And let's say I have that mixed up in front of me, and then if I just pick up an envelope and um, starts asking questions, does it become a random sample? Is there any randomness there? Can you see that? Is this a simple random sample? I mean, for being simple, you have to have the equal probability of being chosen, right? So when I seal your name and mix those up, and then start picking one after another, is there any randomness, or am I being biased somehow?
No, it's random.
Anyone else? So yeah, that's right. I don't really know which name it could be. I don't really have any other specifications. For example, no male or female, uh, uh, or no different age groups, no different ethnicities. All are mixed up with each other. People from different states, or from different major as well. Yeah, our class is so diverse. I really like it for this diversity. I have um, people from fisheries, from English, from journalism, from uh, biology, different places. So all are here, and I'll start picking up names. I don't really know which name it could be. So yeah, this will be a simple random sample. Can you see that? When you start, playing with these definitions, and you start getting it in favor of you, I mean, when you see that what you are imagining actually matches with the actual result, then you'll feel really, really good. There is no better feeling than getting the results, getting the result which matches the actual one, right? Okay, so in example 7, we're doing the similar thing, but now, although it's impractical kind of, it's impractical that you write down all 1,000 names and put it in a big hat. It's impractical. Mathematically, it's possible, but technically, it's impractical. But yeah, for example, we can assume that somehow or other I have written 1,000 names and I put it in a big hat, and then I'm just trying to pick up a name from that. So yeah, it's definitely going to be a simple random sample. Okay. For a large data set, obviously it's, as I said, it's impractical to do this on hand or do this by yourself. But obviously the technology is here. We can actually use our computer to do that. For example, in maths, although I'm not a statistician, we hardly do any statistics course for the graduate study. Well, although maths and statistics are kind of related to each other, but not exactly. So in maths we do a little bit of statistics, and often we are required to, let's say, pick up a number uh, between 1 to 10,000. So there are 10,000 possible numbers. So it's difficult to just start picking up those without, or rather on hand, right? What we do, we set up a program to randomly pick up numbers depending on how many do you need. And when you're setting up a program on computer, you can actually uh, do this randomness for even a larger set, let's say for 1,000,000 of numbers. Okay, so it's really easy to do that on computer, although often for a large data set it's difficult to do that on hand. Oh, okay, so I can actually give you a real life example of it. So when I set up the question, I actually provide uh, a range, let's say um, um, from 1,000 to 1,000 to 2,000, and I call randomness for that range. So when you see the question, obviously 30 or there are 38 of you, and you don't really see the exact same number for a particular question. Let's say for the uh, population of Laramie, which you did in the last exam. Okay, so the population was actually picked up randomly. I gave them a range and said, for each student, give them a random number. It may or may not match with each other. It may match depending on how many trials you have, because I guess you could have tried 3 different questions. The question would remain the same, or only the number uh, will be changed, right? So where does this different numbers come from? I actually give them a range and say, give them a number randomly from that range. So when Nadia uh, starts doing the question, she might have a 1,500, because I've given them the range of 1,000 to 2,000. When, let's say, Aston starts doing that, he might get a 1,750. Can you see that? Can you see the randomness? So I give them a range. I'm actually disclosing the question anyway. So I give them the range and say, give the students a number randomly picked up from this range. So it's really easy for the computer to just pick up, even though I give them a large range, it's quite easy to do that for do that randomness. Okay, does it make sense, everyone? Is there any concerns? Alrighty, so let's see what we have next. Okay, we have one more definition on this page, which is sampling variability. Okay, all right. Now, uh, if you remember, I did say when you do this randomness, there will be some issues, there will be some problems which will arise. You know, nothing is flawless, obviously. So when you do this randomness, when you start doing, or rather picking up people randomly, then you might encounter a problem. You might um, see some problems being arisen. What these problems could be? Okay, let's see a couple of examples. So if you start, I guess I gave you one example where I said the pollster um, goes to Walmart one day on the Grand Avenue the next day, and etc. Right? So can you see problem there? I mean, can you imagine a problem or issue that the pollster could face? Try to uh, use your intuition. Just try and imagine what the pollster uh, could face that might be a problem. Remember, the first day he went to Walmart. The second day he's walking around the Grand Avenue, and um, start collecting started collecting data from the people on that Grand Avenue. So can you see any problem he might face in those 2 days while doing this randomness? Anyone? What if I say, okay, I have one in chat, let's see. Maybe the same people. Exactly. Exactly. Very good. Although it's possible that he might remember that uh, he might remember by face, that yeah, maybe I have seen him on in Walmart the last day, but it is just a possibility. It's the likelihood he might imagine. But the thing is, he might encounter the same people, and not exactly all the same people, but there could be, let's say he has actually mm, collected data from 100 people from Walmart the last day, and today he's planning to do a similar work. He's planning to collect data from at least 100 people. So there is a possibility that he might take or might approach the same 2-3 people from yesterday as well. Can you see that? That's on one possibility. Or let's say the people on Grand Avenue, most people on Grand Avenue are somehow the supporter of the Democrats, not the Republicans. So if you just go walk around the Grand Avenue on that day, then you might be collecting data uh, from the people who will give you or who will actually represent the Democrats. So when you stop uh, or rather, when you finish the survey, go back to your room, go back to your drawing board, you will see, hold on, today I have about 80% votes going in favor of Democrats. That could be a possibility, or vice versa. It could be for Republicans as well. Can you see that? So that could be another possibility. Or let's say on Grand Avenue, uh, I'm repeating the Grand Avenue because I'm just trying to give you the exact same uh, day's result. I'm talking about the second day's result, not the first one. Just try to imagine those things. Okay, so let's say on Grand Avenue, only the not only, mostly the young and uh, young students and young people are walking around or doing their jobs and all that, because there are tons of shops there. There are tons of food stores and all that. So mostly there are young people. That means newly registered voters. So there is a possibility, there could be a possibility, then you are taking or collecting data from a certain age group of people. Can you see that? All I'm saying that you might face these problems. The problems might encounter even though you are doing this randomness. Right? Does it make sense? Okay, now the next definition, which was, I guess, the part of pre-class assignment. I hope you have already seen this definition. You have this at the back of your head, and probably you have memorized it as well. Even if you don't, even if you didn't, no worries. So sampling variability, what's that? The natural variation of samples. The natural variation. Now, what does this mean? So when you're doing this randomness, you can see there is a variation. Variation of what? Variation of different things. As I said, variation of age group, variation of uh, ethnicity, variation of supporters. There will be a variety of supporters. Some might support the Democrats, some might support the Republicans, some might say, nah, I don't really like either. Some might say, I'm not even interested in voting. You might see that, right? So there is a natural variation when you're randomly picking up people, randomly collecting data. So we say that this is the sampling variability. And of course, there will be some unavoidable and some expected issues while you're trying to um, trying to do this randomness. There will be some issues in this random sampling, but that won't be any problem because you can't really fix this completely. When you are doing this randomness, it's most likely that it's representing the entire population and it's giving you the best possible result, but there may or may not be some issues. Okay, so first of all, is the definition clear? Is there anyone who is kind of uh, struggling to understand the definition? Don't feel hesitated. Okay, don't be hesitated. So just, if you have any hesitation, just let me know. If you're hesitated that whether or not you should say that now, no worries, we can definitely chat anytime later. Just let me know, but make sure, please and please, that you actually understand the definitions. It will be really, really important. Okay. All right, let's see, what do we have now? Okay. Okay, next one we have is the stratified sampling. Okay, so for this one, I guess first of all, let's see the definition, and then I'll hopefully I'll be able to um, explain it with an example. So in stratified sampling, a population is divided into a number of subgroups, or in other words, we say it's strata. Okay, so random samples are then taken from each subgroup with sample sizes proportional to the size of the subgroup of the population. Okay, now what does this mean? Now I have subdivided the population into several parts. I have subgroups of the main population, and now I am picking up data from each of those groups. That's the main thing. I have several groups. I may have tons of groups. So I have several groups, and I'll still keep doing the random sampling, but now the samples are taken from each of those groups. First of all, you have those groups, and now you'll be doing the randomness. Excuse me. Okay. Now, what does that mean? So, for example, the 38 students we have in this course, let's say I'll have 4 groups, 38. So yeah, I can say I'll have 4 groups where the first group will be the students from science. The second group will be the students from business. The third group will be from arts and humanities. And fourth group will be for the students who haven't really decided as yet. Let's say, just for example. So I'll have 4 groups out of those 38, and it doesn't matter whether or not I'll have the same number of people in each group. Obviously 38 is not divisible by 4. You can't really divide it by 4, so you can imagine that there will be different number of people in each group, and that's not a problem. So I might have 5 in one group, I might have 13 in another group, doesn't matter. So I have these 4 groups, and now I'll be collecting data from each of these groups, but randomly, not from everyone. Let's say I'll take data from each of these group, and I'll pick up 2 from each group. I'm still doing this randomness, but I'm keeping an eye on the subgroups as well. So this might be said that it's a stratified sampling. Does it make any sense at all? I know this is just the beginning, so some things might be confusing. But what we're trying to do here is we're trying to go really slow. Not really slow, but we're trying to do it slowly and steadily, and trying to go as deep as possible. Okay. So we'll stop it here. Next up, your job is to see example 8 before we meet on Monday. Or is it? Yeah, on Monday. Yep. And meanwhile, if you have any question, even during the weekend, I'll try to just email me. I'll try to answer as soon as possible. Okay. All right. So take care, and I'll meet you on Monday.
Thank you.